Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department as SN80 Adoor. Today I am going to teach you about another problem in LMTD method. This is problem number 2. Question is exhaust gases, that is Cp is equal to 1.1 kilojoule per kilogram degree centigrade flowing through a heat exchanger at the rate of 1000 kilogram per hour are cooled from 450 degrees centigrade to 170 degrees centigrade. And the cooling is done by water having Cp 4.187 kilojoule per kilogram degree centigrade that enters the unit at 15 degrees centigrade at the rate of 1600 kilogram per hour. If the overall heat transfer coefficient is 510 kilojoule per meter square hour degree centigrade, what heat exchanger area is required to handle the load for A. Parallel flow arrangement and B. Counter flow arrangement? This is the question. Okay. From the question itself, it is given that the exhaust gases Cp is given and its mass flow rate is given as 1000 are cooled from 450 degree to 170 degree, means that this is a hot fluid. Cooling is done by water and Cp given it enters at 15 degree, means cooling water is the cold fluid and its rate of flow, that is mass flow rate is given and overall heat transfer coefficient is given. We have to find out the heat exchange area for parallel flow arrangement and second one counter flow arrangement. Okay, then you have to write out the given data, that is first of all hot fluid. The exhaust gas is the hot fluid. Its CPH, that is specific heat, is given as 1.1 kilojoule per kilogram degree centigrade. The mass flow rate of hot fluid is, that is m dot h, is given as 1000 kilogram per hour. We have to change it into kilogram per second by dividing the value 1000 by 3600. Then inlet and exit temperatures of hot fluid, that is T1 is 450 degrees centigrade and T2 is equal to 170 degrees centigrade are given. Then cold fluid, here water is the cold fluid. Its CPC, that is specific heat of cold fluid, is given as 4.187 kilojoule per kilogram degree centigrade and mass flow rate of cold fluid is given as 1600 kilogram per hour. You have to convert it into kilogram per second by dividing it into 3000 by 3600. Then T1, that is inlet temperature of cold fluid, is given as 15 degrees centigrade. Okay, hot fluid CPH is given, m dot h is given. We have to convert it into kilogram per second. Then T1 and T2 are given. Overall heat transfer coefficient given. Cold fluid is water. CPC, that is specific heat capacity of cold fluid, is given. Mass flow rate of cold fluid is given. Small T1 for cold fluid is given. U is given in kilojoule per meter square hour degree centigrade. We have to convert it into kilowatt per meter square degree centigrade by dividing it by 3600. Then to find, we have to find out two values, that is heat exchanger area for first one parallel flow arrangement and the second one is counter flow arrangement. Okay, then our solution, that is first of all the outlet temperature of the cold fluid is, that is small T2 is not given. That is we have to first find out the outlet temperature of cold fluid, that is small T2. Small T2 should be found out first. That is, we know that heat removed from the exhaust gas is equal to heat absorbed by water. That is the concept. That is heat given out by the hot fluid, which is equal to heat absorbed by the cold fluid. That is the concept. That is heat removed from exhaust gas is equal to heat absorbed by our cold fluid, that is water. That is heat removed from exhaust gas is mass of the hot fluid m dot h into specific heat of hot fluid CPH into temperature difference of hot fluid, that is T1 minus T2, which is equal to mass of cold fluid into specific heat of cold fluid into temperature difference of cold fluid. Okay, that is substituting the values. M dot H is 1000 divided by 3600 into 1.1 into 450 minus 170 is equal to 1600 divided by 3600 divided by 3600 into 4.187. CPC is 4.187 into T2 is not given, that is T2 minus T1 is given as 15 degree. 3600 can be cut down on both sides and we get T2 minus T15 is equal to, final answer is, that is 1000 into 1.1 into 450 minus 170 the whole divided by 1600 into 4.187, that is 45. T2 minus T1 is equal to 45.98. 45.98. T2 is equal to 15 plus 45.98 plus 15, that is 60.98 degrees centigrade. T2 we get the value of 60.98 degrees centigrade. Okay, this is the answer for T2. First of all, we have to find out the value for area for a parallel flow heat arrangement. That is, first we have to draw the temperature distribution diagram. First we are drawing the curve for hot fluid, that is exhaust gas, then cold fluid, that is water. Okay, then inlet temperature of hot fluid capital T1 is equal to 450 degrees centigrade and outlet temperature of hot fluid, that is T2 is equal to 170 degrees centigrade. Then inlet temperature of cold fluid small T1 is equal to 15 degrees centigrade. Outlet temperature of cold fluid small T2 is equal to 60.98 degrees centigrade. Then the left side temperature difference of the temperature distribution diagram gives the value for theta 1 and the right side temperature difference gives theta 2. That is theta 1 is equal to capital T1 minus small T1, that is 450 minus 15, which is equal to 435 degrees centigrade. Then the right side temperature difference theta 2 is equal to capital T2 minus small T2, capital T2 minus small T2, that is 170 minus 60.98. The value for the small theta 2 is 109.02 degrees centigrade. Value for theta 2 we get. Next we have to find out the value for LMTD, that is theta 1 minus theta 2 divided by ln of theta 1 minus theta 2. Substituting the values we get for 35 minus 109.02 divided by ln of 435 divided by 109.02. We get the value for LMTD for parallel flow arrangement as LMTD is equal to 235.6 to 135.6 degrees centigrade. That is the value for LMTD for a parallel flow arrangement. So we have to find out the heat transfer. That is Q is equal to transfer Q is equal to m dot h Cph into T capital T1 minus small t capital T2. Substituting the values we get m dot h in the value 1000 divided by 3600 into 1.1 into capital T1 450 minus small t capital T2 for 170. We get the value as Q is equal to 85.56 kilowatt. Okay. Also, heat transfer Q is given by another equation, which is Q is equal to UA LMTD. From that equation, A is equal to Q divided by U into LMTD. Q value we know 85.56 divided by U is given as 510 divided by 3600 into this LMTD value, that is 235.66. We get answer area for 2.563 meter square. That is area for a parallel flow arrangement. The area is equal to area of the heat exchanger is equal to 2.563 meter square. Then for a second part is for counterflow arrangement. You have to draw the temperature distribution diagram. That is, first we are drawing the hot fluid, exhaust gas. Since it is a counterflow arrangement, the arrow is for a cold fluid is from left to right. That is a difference. Sorry, right to left. That is a difference. Okay. Then mark the temperatures. That is, capital T1 is equal to 450 degrees centigrade, and capital T2 is equal to 170 degrees centigrade. And we have to mark T1 in the right side. Okay, small T1 in the right side. T1 is equal to 50 degrees centigrade, and small T2 is equal to value for small T2 is 60.98. Small T2 is 60.98 degrees centigrade. Then the left side temperature difference gives theta 1, and the right side temperature difference gives theta 2. That is, we have to find out theta 1 value. Theta 1 is equal to left side temperature difference, that is capital T1 minus small T2 is equal to 450 minus 60.98. Value for theta 1 is 389 degrees centigrade. Then theta 2, that is right side temperature difference, that is capital T2 minus small T1. Okay, that is 170 degree minus 15. We get theta 2 is equal to 155 degrees centigrade. Then the next step is to find out the LMTD. Same equation, theta 1 minus theta 2 divided by ln of theta 1 minus theta 1 by theta 2, and substitute the values. 389 minus 155 divided by ln of 389 divided by 155. We get LMTD for the counterflow arrangement as 254.3 degrees centigrade. LMTD is equal to 254.3 degrees centigrade. Okay, this is the value for LMTD for. We know that Q is equal to UA LMTD. Therefore, area is equal to Q divided by U into LMTD. The value for Q we have already found out the value as it is 85.56 divided by U value 510 by 3600 into 254.3, that is LMTD value. We get the answer as 2.375 meter square. This area of counterflow arrangement, area of the heat exchanger for counterflow arrangement is 2.375 meter square. Okay. Thank you for watching this video.